Hi, in this video we're going to talk about vertical shafts and why I call them vomit shafts. We're also going to talk about the Model 42 versus the Model 46 opposed twin Briggs. 46 being the 20 horse and this being the 18 horse. Okay, now I'm going to start with why I call these vomit shaft engines, and that's because they are engines waiting to puke a rod. Okay, now this is from this engine. This is the piston number 2, the one lower down the engine furthest away from the flywheel. This is piston number 1, the one closest to the flywheel, and as you can see, this is the one that gets hotter and suffers the most damage. See, that's actually burnt on, caped up oil in there, and this one is still clean. Okay, that's because this is higher out of the oil, and it's relying on a gear. Here, this is a sump from this engine with the same sump in both engines. This is all it relies on to lubricate this engine. This gear has to spin and throw the oil up from the bottom of this engine up into the cylinders to lubricate them. Okay, so when you first start this engine, it takes a while for that oil to work its way up to the top and lubricate everything. So they always tend to lose the number 1 rod. Okay, so the first thing I did with this engine is I wanted to take a look at the condition of it. And it's got some cross hatching in here. I talked about that in another video. I can see the piston skirts. Let me see if I can't get rid of that shine. Hard to tell. But you can see the tooling in the piston still. It's not worn away to a dull finish like this one. It's not all scratched away. So I can still see the machining in this piston when it was sticking out, like this one. I think you can probably see that one a little bit better. Maybe. Let me see if I can't zoom in on that. Yeah, there we go. You can see the machine lines in there. So I was hoping this engine would all be happy, no major problems, but I pulled the piston out. I saw all the scoring in there, and that's not a good sign. So I pulled the rod cap, and this is what I find. You can feel that's actually the original finish in the center, and the outside is where it's been eating. As a matter of fact, I could be wrong on that. No, I'm wrong. That's just eaten away. That's actually where it's welding. Just the rods fall apart on the upper half of these engines, so that's why I like to call them vomit shaft engines. This is where the oil would come in. It's just not very nice. That's bad and not good at all. I'll bet you the clean away. That's actually where it's welding. Just the rods fall apart on the upper half of these engines, so that's why I like to call them vomit shaft engines. This is where the oil would come in. It's just not very nice. That's bad and not good at all. I'll bet you the clearance are probably out of spec on that as well. This engine did run, but I didn't run at full speed, so I didn't hear if it knocked or anything like that, but this had oil in it when I got it. What happened is it probably sat and someone just went and fired it up and didn't go tilting it the different direction to get oil and lubrication up and everything. But even then, this is just what happens to them. This piston is still clean, so it's had oil changes. It was never overheated at any point. So it's just the way these things are. Another problem with these things being turned on their face is the orientation of the pistons. Instead of on a horizontal shaft engine where it'd be sitting on the way the piston would be sitting on the skirt, when you have a vertical shaft engine, or like I call vomit shafts, we're sitting on the rings of the piston. So there's not much keeping these pistons from knocking over time. So these tend to eat out cylinders as well. This one actually fared out pretty good. Matter of fact, I took rings out of this engine and put them in another engine because they were still good. These are the rings that right here that came out of the one engine that was just toast. Let's see if I can't zoom in on that. Yeah, there's just nothing left to that ring. That's the bad side. Let me get that dirt off there. I can get this focus. Come on, you. It's just being stubborn now. By the way, that's the better end, and if you compare that to this other end, it's shot. That's just something that happens to these over time. Anyway, I digress. Continue on. Okay. Now this 18 horsepower block, the Model 42, has very little cutting in here and here, as well as some lack of casting here in the cam for the rod clearance. Now you come into this engine, and there's a whole lot more ground out of that engine. Let me see if I can turn that out of the way. Hang on. Just saying, there's a whole lot more ground away out of this block. You can almost see it's cut down all the way to the corner. There's a whole lot more ground out of this block to clear the longer stroke, as well as the rods are actually canted a little bit to clear the cam. So I'm not sure if I can fit the longer rods in here with this longer stroke. So I'm going to have to convert this block to a horizontal shaft. I don't want to have to cut an 18 horsepower block to fit the longer stroke. And that's one of the reasons why they went to the big bore engines later on, so they wouldn't have to do all this machining to fit the bigger crankshafts. They just rather put the bigger cylinder sleeves in when they cast the engine blocks and keep the 18 horsepower crankshafts. Cuts down on parts and also cuts down at manufacturing time. That's one of the nice parts about this engine. It's got the longer stroke crank. And this crank is going to have to be machined down. There's no doubts about that. And I also have to shorten this shaft down in order to fit the application for my tractor. So this is probably going to cost me hundreds of dollars to have this crank prepped to be able to fit a horizontal shaft. But I think it'll be worth it when it's all done, because it's going to be a nice powerhouse when I'm done. Now, today I want to figure out the deck height which is the distance between the crank center line to the deck. Okay, and this has a what do you call it? 0 thousandths into the hole. It's a flat top. It comes right up to the top of the deck. The piston, I'm sorry. So I want to know how long the rods are, and how long this compression height is, which is the center line of the pin to the top of the piston, so I can order shorter pistons. But it looks like I need probably 1/4 of an inch or something like that in order to clear the top of the deck if I put longer rods in here, which I gotta experiment to see if I can even get them to fit. See if I can't order thinner pistons for these. The smaller piston will be a lighter piston, and it'd be reducing the rotating masses, so more of the horsepower can go into storing energy into the crankshaft. So that's some of the plans. I gotta measure it and see how long I can go, and what I have tolerances for. But looking at the unique shape of the rods and how close they come up to the tappets, I mean, they come really close to the tappets. Let me see if I can't get this set up and show you how close that tolerances are with that rod. Hang on. Okay, these are both 42 models. This one's a vertical shaft, and this one's a horizontal shaft. Some of the difference between these, now if you look at the casting here, we have a lump here, and we have a lump here, and we have a hole down here, and there's a hole down here, so the bushings are the same on both of these. But we have the oil fill into the block on this one, and we have the oil fill on the sump on the vertical. Now, some of these vertical shaft engines did have the whole bored and threaded, and they just stuck a plastic plug in here. So the castings are the same, and if you had to, you could bore this out and put a ridge in here on the dipstick for an O-ring to seal that up. That wouldn't be that hard. So that's that. Now, next thing is let me get this turned up here. Actually, no, I think this might work. Now, let me flip this one up. Hang on. Okay, now, the valves are all the same. Valve ports and valves, they're all the same on both of these engines. On the later year, they did start putting seals in here. Some valve guide seals, that was about it. Now, this was the upper cylinder of the engine. This would be where your crankcase would breathe. So this would be where your lubrication would come in. There'd be a fog of oil mist in here to lubricate these valves. There's a baffle up underneath here that would go, that's recessed into the block. Not sure if you can see into that hole too well. But yeah, the baffle comes out to about here, past these holes. And this one, the lower cylinder, doesn't have any holes in it. Let me see if I can't get the light over here. There's no holes in the valve cover on the lower half of the cylinder, because this one would be closer to the oil, so it gets more of a fog. Now, if you look in here, you'll see all this dirt in here. That could just be because this runs a little bit hotter because there's less oil in here, but that's hard to say. Could just be that there's less oil flow to keep it clean, and that's why it's stained a little bit. One of the things that are just different. So if we look at this one, that hole is right in line with the connecting rod. So as that connecting rod goes down into the block and picks up the oil and swings around, that oil rotating the rod rotating throws oil up into this area and lubricates the valves. And then there's a little tiny hole down there in the corner. Let me grab a pick to point that out. That hole down here is where the excess oil would drain out. There's no hole on this side. I don't know if, yeah, this one's got the same thing. It's got a hole down here for the excess to drain out. Let me move this out of the way, hang on. And this side also has the drain back hole back in that corner. It's just hard to see it. But yeah, that's where the excess would go, as it drains out those holes in the bottom. So for this to get lubrication, if you converted it to a horizontal shaft engine, you'd have to drill a hole down here at an angle like those holes for lubrication to come up and through here. You do not have to worry about the bushing on this side. You won't have to worry about changing anything with the bushing for that oil hole for the bushing, I'm sorry. So that's all the same. That should sum it all just about up. Now, while I'm here, for those of you that probably look for information on fuel additives, this engine, while it's been in my tractor, I just pulled this out a few weeks ago, has always been run with high-octane super fuel with the seafoam additive in it, which was 1 ounce per gallon. I was kind of surprised to find some results in here. Let me show you some of the heads from the Model 46 I had gotten recently. So these are the heads from the Model 46. This is kind of typical as to what I see in these. Sometimes I'll see more carbon buildup in them than this, but this is typical. Let me show you how the heads looked on this, since this was running seafoam. Quite a bit different. These are actually pretty much clean. The stuff that's here is almost just rubbing off. And this is even an engine that was burning oil quite a bit too. Let me turn this around quick and I'll show you what I mean. Yeah, this side wasn't burning the oil. And it's not really all that dirty. Let me just wipe my hand off, or my finger. This is the side that was burning oil. And it's just disgusting. It's just slimy in there and everything. Meanwhile, let me see if that was the head for this side. No, that's not the one head. Yeah, this is the head from that side. Now it is just a little bit dirty on this side that was burning the oil. A little bit more dirty than the one that wasn't burning the oil, but it's still pretty clean in here. So that seafoam does in fact work, so I thought that was an interesting thing to see in this engine, because this thing actually burned oil and it's still no real amounts of carbon buildup in here. You can actually see quite a bit of, there's a ledge right here of buildup of carbon, but everything else is pretty clean. That's because this is by the exhaust, which gets really hot in the engine, so you're going to see carbon buildup around by where the exhaust is at. But really nothing serious. Even the piston isn't all that bad down here. Most of the stuff would just scratch off. I don't have to scrape it out with a knife or anything. This side's not too bad. This has a little bit of stuff right here, but that's the only spot right here. Everything else is pretty clean. That's for carbon buildup. There's some on the valve. Even that's just rubbing right off. So there's some information on that. It'll be interesting to open up my Vanguard and see how clean that is. But anyway, there's a good quick video on the differences between the horizontal and vertical shaft engines. Model 46 and Model 42. Matter of fact, while I'm here, I'll give you some specs. The Model 46, the 46 cubic inch, 20 horse, has a 2.46 inch stroke, and these two Model 42s have a 2.28 inch stroke. That's really the only difference. And like I said earlier, they mill the blocks out more for the longer stroke, but the bores are still the same. Okay, so I hope you liked that video. If you did, make sure you give me a thumbs up. And as usual, I'm going to wish you to have a good day, and I'm sure I'll have more videos out in these in the future, so thanks for stopping by, and